yesterday we talked solely about the multiplication of polynomials. So if I have 5a, I have a plus 5 here. Okay? So the distributive property says that I multiply 5a through the brackets, which gives me 5a times a, which is what? 5a squared plus 25. 5 times 5. Okay, now, this is the multiplication part of it. The other part of it, which to me is the most important part that you're going to do, because when it comes to grade 11 applied, grade 12 applied, 11 pre-calc, grade 12 pre-calc, you do piles and piles and piles of what we call factoring. And factoring is taking a term or a set of terms, finding a way to make them smaller so that it actually enables you to solve a question. Everybody's got a smart, get focused here. There's 3 or 4 of you staring at the ground right now. This is the most important thing that you're going to take from now through the next 2 years. You have to learn this skill because you do it over and over and over again. All right, so here's what I'm saying. The very first thing I will tell you to do when it comes to factoring is you look for what we call a greatest common factor. Okay? So the greatest common factor is a value that goes into both of them, and the largest one possible. So what do I mean by that? If I have 8 and 12, let's say, I want the greatest common factor. I want the largest possible value that can divide evenly into both those numbers. 4. 4 goes into 8 how many times? 2. And 4 goes into 12 how many times? 3. So that's what we call the greatest common factor. The value that goes into both of the terms I'm talking about. So when I go back to this guy, I want to work it backwards. So I start by looking at 5 and 25. What's the largest value that goes into 5 and into 25? 5 does. What's the largest value that goes into a squared and into a? A. So I'm going to take a 5a out of here. And when I say take it out of here, I mean divide it out. That's essentially what factoring is it's dividing. So when I take 5a squared and I divide it by 5a, what am I left with? A. And when I take 25a and I divide it by 5a, what am I left with? Just 5. That's what we call factoring. This is a skill that we always want to look at and say, okay, if I have to factor something, the first thing that I always want to do is find the greatest common factor. And you're going to hear me repeat this over and over again as we go for the next couple of years. When you're looking at something and you're looking as to how to factor it, I'm going to say to you, what's the very first thing that you do when it comes to factoring? And you're going to say, greatest common factor. You do it every single time. Okay? Now, it's not always that it works. There may not be a greatest common factor. And you'll run into that. But if there is, we need to take it out first. So the example in the book that they use is this. All right, I'm going to make this look very simple towards you, okay? The first thing you do is, I'm going to just make it, I don't need this, but I'm going to put it out on the outside anyways. I'm going to put a set of brackets out here, which is going to hold my greatest common factor here. So the first thing you're going to do, what is the largest value that goes into 2, 8, and 12? 2 does. Oh. 2 does. Now what I'm going to ask, is there an m in all 3 of them?
Yeah.
So there's a greatest common factor in m. Now when it comes to variables, the easiest way to think of it is the greatest common factor is the smallest exponent on the variable. Okay, so that kind of contradicts yourself a bit, right? So I have an m cubed here, an m squared here, and an m there. So which value goes into all 3? M does. It's the smallest exponent of the 3 variables, right? M cubed does not go into m evenly, but m goes into m cubed. M goes into m squared, m goes into m. So I take the m out. Is there an n in each of these? Yeah. So what's the greatest common factor in terms of n's? It's an n. All right. So there's what I've taken out. I have divided a 2mn out of here. Which means if I were to multiply it back in, I'll get the same answer I started with. So now, what is 2m cubed n squared divided by 2mn? What does it leave me with? Well, what's 2 divided by 2? 1. What's m cubed divided by m? M squared. We subtract the exponents, right? N squared divided by n? N. Okay, so far? 8 divided by 2, or negative 8 divided by 2? Negative 4. M squared divided by m? M. N divided by n? What is it? It's not 0, it's not nothing, it's not n. What is it? Who said it? 1. Anything divided by itself is 1. Do we agree? 4 divided by 4 is? 5 divided by 5 is? N divided by n is? 1. I don't write it in there, but you don't say 0. Because if I put a 0 here, 0 times 4m is? 0, so it doesn't exist, right? So you don't put a 0 in there. Okay, it is a value, it is 1, you just don't have to write it in there. Okay? And then 12 divided by 2 is? 6. M divided by m is? 1. N to the 4th divided by n is? N to the 3rd. There it is. I took out my greatest common factor, and this is what I was left with. How are we doing? This is opposite of what we did yesterday. Yesterday we started with this and we multiplied it through. Today we're working backwards from what we did yesterday. This is the dividing part. This is called factoring. Absolutely. Okay, I just want, any questions about this? Go ahead, Morgan.
So it's taking that and dividing by all that, like, okay, so so everything will be divided by 2, right?
2mn.
Yeah, 2mn.
Yes. Yes.
And then the to
And then
2mn.
whatever I'm left with goes in this bracket.
Okay.
Okay?
Okay.
All right. Let's try another one then. Okay. What's the largest value that goes into 12, 28, and 8? 4? Anybody disagree with that? We're all okay? 8 doesn't go into all 3?
No.
It doesn't. 12 divided by 8 is not an even number. 28 divided by 8 is not an even number. The largest value that goes in is 4. All right. Now I'm going to look at my x's right now. Which x has the smallest exponent, and what is it?
8x squared.
X squared is the smallest of the x's there. So that's the one that comes out. Okay? All right? Now I have y to the fourth, y squared, and y cubed.
Y squared.
Which one?
Y squared.
Y squared. Take it out. All right. 12 divided by 4 is 3. X to the fourth divided by x squared. X squared. Y to the fourth divided by y squared. Minus 28 divided by 4. Negative 7. It's important. X cubed divided by x squared. X. Y squared divided by y squared.
Y.
What is it? 1. Don't say y. Once you, anything divided by itself is going to be 1. Right? Okay? 8 divided by 4. 2. X squared divided by x squared. 1. Y cubed divided by y squared. Y. There you have it. Greatest common factor is what? What is it? Or what?
4x squared y squared.
4x squared y squared. The whole thing is the greatest common factor. That's why it goes in front. Now, if I were to multiply it through, this times this would give me that. This times this gives me that. This times this gives me that. Okay? How are we doing so far? Sure. No, that's fine. We can do as many as we need until we get it. Okay. I need the greatest common factor. Yeah, right. Oh, you want to answer already? Okay, so starting with the coefficients, that's the numbers. We call those coefficients. What's the largest number that goes into 35, 15, and 5? 5. X squared, and x. What x? Y squared, and y. Y. Okay, 35 divided by 5. X squared divided by x. Y divided by y. Good. 15 divided by 5. X squared divided by x. Y squared divided by y. 5 divided by 5. X divided by x. Y divided by y. I have to put that 1 there. I have to put that 1 there. Okay? So here's something new to you. We actually divided out a whole term. So I have to put that 1 there. Now how come I have to put that 1 there? Well, what would happen if I did this? I would multiply that through, and what would I get? 35x squared y, 15x squared y squared, and then that would be it, right? But that's not what I started with. So if I divide a whole term out, I have to put a 1 there. Okay? Everybody okay so far? Yeah? sorry, I'm just thinking now how I want to go about the next order of business here. How many of you finished 5-1 yesterday?
Like up to apply.
No,
Or
I
like
just, okay, well, all right, let's go up to apply. How many of you got to the apply, got to the end of 8? Just one? Couple of you? Say you got, how far is in? Okay. Okay, good so far. All right, I'm going to show you this. Just because again, I'm away on Monday. Now, so, I'm gonna review a bit of yesterday and then I'm gonna show you how it applies to today. Okay, and it's very, very similar to what I just did. All right? Yesterday I would have asked you to do this. Okay? And I said, okay, let's multiply this. What was it that we used? What was that method called? FOIL. So if I FOIL this, what do I get?
X squared.
X squared. What's 3x?
9x.
9x. Add 27. Okay, before I go any further, I need you to see something. That last number is 27. That value is always the last digit times the last digit. That's why we say it's the last in terms of FOIL. Okay? So when I work backwards, the values that go in the brackets as the last two numbers will always multiply to give you this last number here, which is 27. So I'll explain it a little bit better in a second. And the middle value is the sum of that number and that number. Okay? All right? So this works out to x squared plus 12x add 27. That's what it works out to. I now have a trinomial. I had a binomial times a binomial, and it gave me a trinomial. Now what I want you to do is take a trinomial and turn it into a binomial times a binomial. This is called factoring. You're going to work it backwards. So I'm going to take this exact same question. And I'm going to explain how to do this. Step 1. Find the factors of the last value. So we would list those up. And of those factors, they have to add to give you the middle term. Okay? Does everybody understand what I said there? The factors of the last value have to add to give you the middle term. Now, it will switch if I have a number in front of here, but I'm not worried about that right now. We'll get to that after. Okay? So here's how it looks. I put 2 sets of brackets, like that. 2 sets of brackets. What are the factors of x squared? X and x. So I put that right here. Because how do I get this guy? It's my first, right? This times this. So x goes there, x goes there. Now, what are the factors of 27 that add to give me 12? 3 and 9. So I can put them in the brackets, doesn't matter which way. And these are both positive, therefore these are positive, and I've now factored it. I've now worked my way backwards. I've now divided. So x plus 3 times x plus 9 gives me x squared plus 12x plus 27. Okay? This is called factoring. All right? So I'm going to show you a couple other examples of this. Geez, they go right into the hard stuff right away. Let me do a different one. Let's do this guy. Okay. So, first thing I do, if I don't have a value in front of the y squared, I'm going to write down 2 sets of brackets. Okay? And what goes at the start of these brackets? Y and Y. Because those are the factors of that guy. Now I want the factors of 12 that add to give me 8. 6 and 2. 2 and 6. Doesn't matter which way I put it. 6 and 2, because they're both add, I just factored it. That's all there is. Find the factors of that last value that add to give you that middle term. Okay? All right, let's try a different one. Okay. Is there a value in front of the x squared?
No.
Yes. What is it? It's 1. So yeah, there technically is. So if it's not 1, then I have to do something different. But it is 1, okay? So I'm just testing your understanding that there is, you have to respect the fact that there is a value in front, it is 1. But anyways, okay. So, 2 sets of brackets then, correct? What are the factors of x squared? X and x, just like that, right? What are the factors of negative 12 that add to give me negative 1? What are the factors of negative 12 that add to give me negative 1? Roy? Yes. Everybody hear that? What are they? Negative 4 and plus 3. There it is. What's negative 4 times 3? Negative 12. What is 3 times x?
3x.
Negative 4x. What's negative 4x plus 3x? Negative 1x. Okay? Do another one. Okay. What's the value in front of the x squared? 1. So because it's 1, I go 2 sets of brackets. What are the factors of x squared? Okay. What are the factors of negative 28 that add to give me negative 3? Negative 7 times 3? What is that?
Oh, times 4, sorry.
Okay. Just got it. What was it? Negative 7 times 4. Is that minus 28?
Yeah.
And what's negative 7 plus 4? Negative 3. Let's check it and see if we got it right. What's x times x?
X squared.
X squared. What's x times plus 3? What's negative 7 times x? What's negative 7 times 3? Oh, what did I do wrong here?
What's 4?
Oh, there. Yeah. That changes it, right? So that should have been a 4. Which makes that a 4, right? Okay. and then negative 28 here. X squared. What's 4x subtract 7x? Negative 3x minus 28. Is that what I started with? Yeah. Okay, so far? How we doing? How many of us think you got it? Be honest. Yeah? How many of us have no clue? How many of us are so? Okay, let's start. It's a start. Okay, so here's what I'm going to do. I'm going to hit page 91 right now with you. And we're going to go through one question from each. I'll pick the question. We're going to go through it so that you know how to do each one when it comes to your time to do it by yourself. So, first question says, greatest common factor. Just leave your pencils down, watch the board. All I want you to do is work with me on the board. Greatest common factor, 16 and 48. What is it? 8? 16. Which one is it?
16 is 48 divided by 16 is 3.
Right. What is your greatest common factor? 16. 16 times 1, 16 times 3. All you have to do is put the actual value. Greatest common factor is 16. So the first part, all you're doing is finding the greatest common factor of two numbers. Okay, so far? Second part. Again, put your pencils down. I don't want you to write anything down. Okay, greatest common factor. What's the greatest common factor between 20 and 30? 10. Greatest common factor between c squared and c? Greatest common factor between d cubed and d squared? D squared. You guys are nailing it. Everybody understand that?
Mhm.
We're going quick. Going quick, but I think you guys are catching on real quick too. Is that okay?
How do you get 10? Like,
What are the two factors that go into 20 and 30?
oh, to both of them, yeah, then I have to be 10.
That's right. What'd you think it was?
I don't know, it just seemed odd it would be 10. It just didn't look right to me.
Okay, now it does.
Yeah.
Beauty. Beauty. Okay. Number 4 is the same thing as 2. I'm not going to do it. Number 5. Here's an interesting one. I'm going to do it with this. Not sure just yet as to why we do this, but we're going to do it anyways. So far, and factoring, get this in your mind, factoring is all about the greatest common factor. So the value, the largest number that goes into two separate numbers. They're also asking you to find the least common multiple. What does the least common multiple mean? Very good, Brendan. Couldn't say it any better. The lowest number that both those values go into. Where do you use this?
When you're adding factors.
Yes. When I'm trying to find a common denominator. Right? With fractions. You need to know how to do least common multiple. So what's the least common multiple between 3 and 4? What is it? You were right, Shay. What do they both go into? They both go into 12. Right? Not the numbers that go into them. What number do they both go into? That's the difference between greatest common factor and least common multiple. Okay? Just going to do this one as well. What do both 6 and 9 go into?
18.
Both go into 18. And what do x and x both go into? X. That's the least common multiple. Okay? Then it says, the next one says factor. So, I'm going to do this one. I want to factor that. What's the very first thing I tell you to look for in factoring? Greatest common factor. Get that up here because I'm going to ask you that 1,000 times before now in the end of grade 12. Okay? Always look for the greatest common factor. So what's the greatest common factor between 5a subtract 5a and -5? What goes into both of them? 5. So if I take the 5 out of there, what am I left with? Is that it? Erica? Subtract 1. I got to remember that because if I had to put a there and multiplied it back through, it would have just given me 5a. Is that what I started with? No. So you got to remember, if you factor out a whole term, the 1 has to be in there. Okay? The last one I want you to do, this is an interesting one. There's a reason for this. It's leading you into the factoring that I just showed you today. And here it is. This also has to do with factoring of trinomials, but factoring trinomials with a value in front of the x squared, usually, okay? What's the greatest common factor here? What do both of those terms have? Yeah. Just look at them in terms of their terms. You got term 1 and you got term 2, right? There's 2 terms. Do you agree with me? Yeah, what is in there?
Brackets?
Yeah, what about them? Do each of them have them?
Yeah.
And what's inside them?
Equation or exponent.
What is it? What is it? Read it to me.
X equal x negative 6.
X, not -6, x subtract 6.
X subtract 6, yeah.
Right on. There it is.
Oh,
There's your greatest common factor. What do both of them have? They both have this.
Oh, yeah.
So if I take it out and put it out here, so I take x minus 6 away from that, what am I left with? X. And what am I left with over here? Here you go, Morgan. There it is. Still looking for what does each term have. In this case, they both had x subtract 6. We agree? Makes sense now that you see it? Right? And then what was the one way in which I told you that you would multiply these? Well, you could go x times this and 4 times this. Well, that's what that was. So it all relates back to what you did yesterday, working the other way. Okay, so let's try another one. What do both those terms have? R take away 7. And what am I left with when I take it away from this guy? R and subtract 4. There you have it. Okay? Any questions about that? Sure. All right. What do they both have? G plus 6. So I'm going to take the G plus 6 away out of this guy. What am I left with? G. And I take it away from there. What am I left with? Plus 1. You guys are getting it. Nailing it. Good? We good? Lots of sleepy people in here. We good? Okay? This, like I said, is one of the most important things that you're going to do. You have to nail this down because you solve quadratic equations. I mentioned this yesterday. You solve quadratic equations in grade 11 and 12 a lot. And if you can't factor, you can't solve those questions. You have to just factor, 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 and we do so much of it. Probably one of the most important skills that I'll carry over from grade 10 to 11 to 12. Okay? All right, I'm going to shut the camera off, then I'm going to ask if there are any questions from 5-1 yesterday.